So once again, very good afternoon to all the participants. So I think morning Vidya ma'am has given some basics of artificial intelligence. So after that, the resource person have given some basics, and man tried to give a guidance for installing the Jupyter notebook. So because of some network issues, I think the man could not able to continue the task. So ma'am has shared the YouTube link for how to download and install the Jupyter notebook. So first of all, is it audible? Participants, is it audible? Shall I proceed?
Yes, sir.
Okay, fine. Okay. So in this afternoon session, I think it will run 1.5 hour session. We are going to discuss about the decision tree. Okay. So why the decision tree concept is very important in terms of AI and machine learning. So before that, I think this A and deep learning, it should be very new for the students. So quickly, I will give an overview of this machine learning and decision tree. Then after that, immediately I will explain the concepts, and we will try to do some practical session on this Jupyter notebook. Okay. So no need to install. Just we are going to do all the exercise in the online. Okay. So I will give a step-by-step explanation how to open this online Jupyter notebook. So in that, just we are going to open the Python. Okay. So some setup files you have to install. So that I will share in the chat box. Okay. So in the chat box you can get this file. Okay. Because we need a data set for doing this kind of exercise. We need a data set. So the data set is there. So after I have explained the concept, I will share the data set in WhatsApp, as well as I will share the data set in the chat box. So I request all the participants to just install the data set in your online Jupyter notebook. Then we can do the pre-processing as well as classification with the help of this Bayesian tree. Okay. So quickly, I will explain. If you study or if you learn about any concept of this AI and machine learning, so the basic step is nothing but you will have two types of classification. So one is called as the supervised learning, and another one is called as unsupervised learning. So here the decision tree is one of the concept of is one of the concept of supervised learning. So first of all, what is meant by supervised learning as well as unsupervised learning? So before that, I will explain. So here decision tree is one of the concept of classification. You know what is a classification? So here the classification is nothing but based upon some predefined behavior. Otherwise, you'll have some predefined study. So based upon that characteristics or maybe the properties, so you have to classify the data into some types. Okay, so that is a classification. For example, if in a basket you will have different kind of fruits. Okay, so you have to classify the fruit, which one is apple, which one is a mango, and which one is a banana. Each and every fruit will have some shapes. Okay, even though the fruits is having a name, and we will have some predefined shapes. So based upon the predefined shapes, we can easily classify the fruit. So here also in the world we will have a raw data. Okay, so huge amount of data is there, but we have to analyze the data as well as we have to retrieve the data in a very quick manner, and we can analyze the data very fast. Okay, so that's why the data analytics nowadays it's play a major role in all the industries as well as in all the sectors. Okay, so yeah, first we have to do a classification. Okay, so in order to make effective classification, so the decision tree is one of the tools. Okay, so before going to that, discuss about the decision tree. Normal in AI and machine learning, we will have an input. Okay, and we will have an input, and you know what is the output you are expecting from this from the data set, and you have to train a model. Okay, you have to construct a model. So based upon that, this input data will be trained. Okay, so yeah, for example, in simple example, just you want to design a robot. Okay, so the robot doesn't know anything. So in movies itself we have watched, we have to create a schema, Otherwise, we have to create an algorithm. For example, how to move the object. If you want to move a robot, if maybe four options will be there. Either the robot can move left, right, and up or maybe front. Then if there is any obstacle is there, okay, how you have to write algorithm? If there is any obstacle is there, either you have to move front or either you have to move back or you have to move left or right. So the rules, that is nothing but a schema. So you have to train the model. For example, you have to train the robot. How you can train the robot? You have to fetch a rules. If this kind of situation will be happen means your robot has to behave like this. So that kind of rules, everything you have to fed into your machine. Okay, you have to fed into the algorithm. So what your algorithm it will do, it will queue your input and it will be processed, and what kind of output you need based upon that your model you have to implement in terms of your input as well as output. A simple term, the model is nothing but your intermediate between your input as well as output. So you have to train the model. First example, if you have to execute the algorithm. Okay. So your model is classifying only, it is giving accuracy as a 70%. Then you have to identify what is the drawback. Why it is not giving 100% result. Why your model is not accuracy for giving 100% result. You have to tune it. Where is the drawback is there. So that process you have to implement. After that, once again you have to execute it. Okay. And now if you have to check whether you are getting any better result or not. If you're getting a better result, so once again the tuning process has been done. So this until your accuracy is reached to near to 100%. So what you have to do, your model should be trained. Okay. So that is the concept of this AI and machine learning. So the here just we have to do a classification. Okay. So the classification will be done by the machine only. So how the classification process will be start? So the machine doesn't know anything. So simply you are going to give an input and your predefined model will be there. For example, you have to identify the image which is a normal user or maybe an unauthorized user. For example, you are having a machine which has to identify this is the authorized user, that is this is a owner or maybe unauthorized user means in a database the owner will be image will be there, that is authorized image will be there. Okay, and if some of unauthorized image user is entering is try to access the data, what will happen means it will capture the image and it will try to match in the database. Okay, if the captured image is not matched with the image present in the database, so what will happen? So already pattern is there. So already the pattern is fetched in the database. Only thing, what are the inputs we got it, whether it will be matched in the database. So if it is matched in the database, we have to classify that is authorized user. If it is not matched in the database, we have to classify it is an unauthorized user. That is simple logic. So here, that what is a model? So how many shapes, how many data, how many model you are creating? Based upon that, your model will give a better result. If you are giving more shapes, if you are giving more accuracy input to the database, based upon that, it will provide it will give accuracy results. So that is a classification. Normally, how the classification it will be done means based upon your predefined inputs, okay, and how you are given a training for your model, so the accuracy of your output you will get it. So here just we are going to apply the decision tree. Normally, if you have a root node, okay, the similar kinds of your tree, you will have a root node and you will have left path, you will have a right path. Okay, in left side you will have some data, in right side also you will have some data. So yeah, the decision tree it is one of the main tools to perform your classification process. Okay, and what are the steps is there in decision tree? You will have a learning step as well as you will have a classification step. So first, your model should learn. So how your model should learn means you have to give some sample inputs. Okay. So what are the sample input is required for your model? So based upon that, your model should be properly trained. Okay. So directly you can't use it for the real-time field because you have to train your model. That is a learning step like how For example, if you are going for examination, directly you can't able to write examination. You need a proper practice. So how you can practice? You have to study for some durations. So after studying, you can appear for exam. So that is your learning process. So like that also the machine has need a learning process. So how the learning process can be done means you have to give a training. Okay. So you have to train the data. After that, you have to execute and you have to predict the result whether it is matched with your output. So what is the expected output is required for your process. So that process you can check it. And here the decision tree is one of the classification algorithm to understand and to train the data and to make the classification process. Okay. So now we will move on to the decision tree. So here, so already I said that the main will have two types of classification. One is a supervised learning algorithm. Next one is unsupervised learning algorithm. In supervised learning algorithm, so you will have an input, okay, and input also it will be well known for the user. Output also it will be known for the user. Only thing the model should be trained based upon the input as well as the output. Okay. So in supervised learning, you know the input value, you know the output value, just the training process should be done. So that's why here the decision tree it belongs to one of the category of supervised learning. Okay. But in unsupervised learning, so the same kind of procedure only you are going to follow, but at the time you can't predict which one is the output. Okay. In supervised learning, you know what is the output you will get it. So based upon the output only, the input process will be trained. But in unsupervised learn, maybe the expected output may come, maybe the unexpected output also maybe there is a chance to occur. So you can't be able to predict in the unsupervised learning. But decision tree is one of the concepts. It can be applied for a based upon the supervised learning. And already I said the decision tree is used to perform a classification process. Okay. And here already I said that it is like a normal tree. You have to do a classification. So you will have a root node. Okay. And you will have a left node and right node. Okay. So based upon the root node, the process it will be start and it will compare the value of root attribute with the record attribute. Okay. So if it is mapped, it will go for the next values. Okay. So here we will have a historical data because the decision tree will be applied to the data which is already available. Okay. So first thing we have to classify and we have to predict in which type of category your data will be belongs. Okay. So that is a mechanism, that is a problem normally we take in consider of the decision tree. Okay. So here just we are going to classify and you are going to predict the values. Okay. So another one thing. So here I have given an example for your decision tree. So you will have a data that is based upon your previous game. Okay. So learner how you will do. For example, if you are downloading any games from your app from Google Play Store, what you will do? There will be some demo session will be there, or maybe some practice session is there. Why? Why you can't directly able to play? Because if you're directly able to play the games, you don't know the rules and regulations. So for that, you need a training. Okay. So the training should be done for the learners. After that, so based upon your outcome, okay, what are the rules and regulation have been developed? Based upon the outcome, you can able to play the game and you can reach the result to 100%. Okay, so that is a task we have to do with the decision tree. Okay, and here in decision tree, you will have two types of decision tree. You will have two types of decision tree. One is categorical variable decision tree and continuous variable decision tree. So what is this first type, category variable decision tree? The decision tree values should be a continuous values. So decision tree value should be continuous value and based upon that value we have to do a pre-processing. And in continuous variable decision tree, what are the values you are going to store, it may not be, it may be fetched in the random manner. Okay, so the two types of decision trees we will discuss in the upcoming session. Normally already I mentioned, in decision tree we will have a root node. Okay, so it represents the entire populations or maybe a sample of your input values. Okay, and then you have to split the data. Okay, so how you can split the data? So based upon your leaf node, okay, either you can split the data into half, either it should be left node or it will be right node, and here you will have a decision nodes. Okay, so based upon the decision nodes, the node will be splitted, and we will have some pruning concept. So what is, if you want to remove any sub node, so based upon the decision, so that process we can able to do in the decision tree. Okay, I will move on to the next slide. So yeah, what is the advantages? Why we need a decision tree? Okay, so there are some of the valid points for the advantages of decision tree is there. Okay, so the decision tree, it's a simple representation, and another thing, it can be easily to understood. Okay, and the framework. Okay, because what I said here, we have to create a model, so that model should be created based upon the input as well as the output. Okay, so we have to create a framework. The framework of your business tools can be easily performed with the help of decision tree. Okay. Another thing, if there is any problem in the decision tree, that in which node, if you are having any problem, which node is not producing the results, that track of process also it can be easily done with the help of decision tree. And here it is one of the multivariate algorithm. Okay, so there is no restriction. The decision tree can be applied to any type of algorithm. The only thing, it is well suited for the supervised learning. Okay, and these are some of the advantages. And here, the main thing, the decision tree concept, it will be what, based upon the attribute value description. So what is this attribute value description means? For example, I give an example. Normally, if you have a data set, so the data set can be classified into, it is classified into hot, mild, or cold. For example, this is a data set, it is related to the climate. Okay, so if you want to classify the data, means yeah, these are general categories that either it should be called as a hot, or if the climate is mild, or maybe if the climate is cold. Okay, so based upon this attribute value description, the data set is classified, and here we can do a category of classification concept also. Okay. These are some of the overview of your decision tree. And here, so what I said, the decision, it will be start from the decision nodes. Okay, this is the format of your decision tree. Okay, so we will have a root node from which to start. Okay, so this is a root node from which you have to start it, and here it will specify the test, and the nodes can be classified based upon the attributes. Either it may be single attribute or it may be a target attribute. Okay, it will be split into subnode. If it is S means this data will be added in this category. If it is no means the data will be added in this category. Okay, so just this leaf nodes will be attributes. It will give a direction, and it will give a direction for the user in which direction they can proceed. Okay, for example, which node we can proceed. Either you have to move right, either you should move to the left side of the decision tree. So that concept also it can be clearly understood with the help of this decision tree. Okay, and here, and the random split. Okay, so as well as this is a simple example we have taken, but if you are trying to store more number of data, for example, you are trying to store some 1,000 or maybe 10,000 data, so how this random split can be performed in terms of decision tree. Okay, so the tree will be grow as a large. Okay, so like that, I given some sample structures. Then okay, if it is 5 p.m. Okay, just we are going to search data. It has been happened before 5 p.m. Okay, so if it is before 5 p.m. means we know to search data on the left side directly. You can move on the right side and fill start as no. Yeah, if for example I want to search data after 5 p.m. means I need to move towards the right side. And either in that also two cases there, either it should be 7 p.m. or 9 p.m. If it is occurred in terms of 7 p.m., I need to search this second half of your left side data. If it is happened after the 7 p.m., you have to search the right side of data. Okay. So this is a random split is one of the concepts to apply to search the data in which category it has been belongs. Okay. So yeah, this is some of the examples for your decision tree. Okay. So this is a training data set. So what I said, the first set, we will have data. Okay. We have to train the data. After that, based upon the training only, it will provide the accuracy results. So here, for example, I have taken a data set, and this data set is trained based upon some three different categories. So what does the mean? Their output is nothing but either it should be a sunny, overcast, or rain, and here I have given some percentage based upon the temperature or maybe humidity, or if it is windy, we can classify the data. So here, if it is sunny means definitely we'll have some temperature high and humidity 90% and there is a chance for wind. Okay. So this is a data set for playing a game. For example, everyone will know about the cricket. Before the start of the game, the weather will be predicted. Okay. So why means if there is a based upon the three different temperature or maybe three different weather, if there is a chance for an interruption in the play. If there is a more chance for the humidity, the game can be interrupted. If there is a less chance for humidity, there is a less chance for the interruption. Okay, so that's why weather will be predicted. So here the temperature is there, humidity is there, and there is a chance for wind. If the temperature is 56 and humidity is less, there is a less chance for a wind. So here the third overcast. If temperature is more but humidity is there, false. Okay, there is a chance for a play. So yeah, overcast is there, temperature is or humidity is also there, you can be able to play. But here rain, if there is a more chance for the rain, if temperature as well as humidity is there, yeah, wind is even though wind is false, the play can be interrupted because of rain. Because if the rain starts means the game will be interrupted and the game cannot be continued. Okay. So this is one of the training data set. So this training data set, based upon this training data set, the decision tree will be a match with their output, expected output. Okay. So here the classification process it will be done. Okay. So here we'll have a root node, and now I'm just creating the sub node. That is heat node means if it is sunny or overcast and it's a rain. Okay. Now this three categories will become as a root node. Here overcast means even though overcast we can play, but here if it is humidity or wind, there will be chance and there may not be a chance to play. So that's why if there is a humidity, if it is less than 75, we can play the game. If it is more than 75, the play can be interrupted. So in terms of wind also, if it is true, we can play the game. If it is false, the game can be interrupted. Okay. And here, how we can create a rules, because based upon the rules only, we can be able to classify the data. So if it is a sunny day and humidity is not above 75%, then it's a play. Okay. If it is a sunny and humidity is above 75%, then do not play. If it is a overcast, then we can play. If it is a rainy but not windy, it can be played. If it is a rainy but it's wind, then do not play. Okay. If it's a best classification, the question is arise if it is a base classification means We can't say that. Even in morning, it may be the temperature will be more, but after later time, there may be chance to for the rain. But once the rain has been started, the play will be interrupted. So that's why if at that time the accuracy what we have been predicted, it is not given accuracy results. Okay, because what you have predicted that today temperature is good and there is no rainy and the game will not be interrupted. But lately the climate has been changed, okay, but the play has been interrupted because of the climate condition. Okay, so whatever the prediction you have been applied for any kind of application should be true because it's just a game, so that's why it will not affect any research. But some of the real kind of application, but for some of the real time applications, we have to make an exact prediction. Okay, so that is why the decision tree play an important role for classifying your data. So here, some of the example is that if new record outlook is weight and temperature is 70, and even in this true, that we are performing the classification. So what is the classification we are doing? The classification is no clear. Okay, and how the accuracy of classifier it will do, how much percentage of data has been correctly classified. For example, at the morning, even before the game starts, we'll classify. For example, for the 10 games, we are making the prediction. For the out of 10 games, 9 games the prediction is correct, but one of the games the prediction is wrong means out of 10, 9 divided by 10. So it's a 90%. So the accuracy of classifier is only 90%. But out of 10 games, for example, you have classified for 5. Okay, your accuracy of classifier is only 50%. For example, out of 10 games, you have made a prediction for 10, 10 out of 10. Then your accuracy of your classifier is 100%. Okay, so here, so based upon your accuracy of prediction, this classification will be performed. So here just we are mapping the accuracy with your train data. Okay. So here we'll have two records and two conditions we are checking. One is sun and humidity. So one is correctly classified and the one is not correctly classified. So that's why the accuracy will be 50% according to the rule 1. Okay. And according to the rule 2, here also one sun as well as humidity is greater than 75. So one is correctly classified, another one is misclassified. So here in that case also accuracy is 50%. And third category in terms of third one is a overcast. So here also the accuracy is 66%. So based upon your training the data, your decision tree will give a accuracy. Okay. So here in this example, just we are going to take two data sets. Okay, in Python, and for the two data sets, we are going to measure what is accuracy based upon the entropy and mean square error. Okay, so these are the various parameters will be used for measuring the accuracy of your training data. Okay, and these are some of the matrices. Okay, so here we can say that your decision tree it is providing 100% classification. And what is the proof? We will have some matrices. So based upon that matrices, it is used to check the efficiency of your classification. How your data set will be classified. Okay. So here, first matrix is information gain and entropy, and then some of the classification matrices we are going to use. Okay. So here, what is information gain? So for a given data set, so how many data for how many attributes it has given accurate results. Okay, so based upon that information gain will be measured. Simply already said, out of 10, if it is 10 is classified, it's 100%. Out of 10, if 9% 9 attribute is classified correctly, it is 90% accuracy. So that's why even for some of the decision trees will give a good result if the number of attribute is less. But if I have more than 10,000, if you have lakhs of attributes, at the time we have to check whether it is producing accurate results or not. Okay, so that's why the information gain is one of the parameters. It is used to measure to check the accuracy of your decision tree. Okay, and is entropy. Okay, so here entropy we will do two types of classification. One is either it should be positive or it should be negative. Okay. So positive means here what are the results it should be in positive cases and what are the results it will be belong to the negative cases. Okay. So how the entropy should be measured means the probability of log 2 of your positive cases minus probability of your negative cases. Okay. If if all the positive will be predicted correctly, it will give accurate result. If all the negative will be predicted correctly, it will give accurate result. For example, I said that in morning you are measuring that there may be a chance, there may not be chance for the rain. Okay, so that is true case. In that case, if match is not interrupted, it's a true. But you have predicted that in morning there may be a chance for rain. That is false. Okay, but in that case, if rain is not happen, if the play is not interrupted, means that is a negative case. Okay, so both type of cases will be predicted in accurate manner. Then only you can say that your algorithm is more efficient. Okay, so we have to take the positive as well as we have to take the negative samples. So this both training data will be fetched into the algorithm, and for all the type of cases, it has to give a accurate result. So here I'll give an example. For example, S is a set. We will have 25 example. 15 it will give a positive result. 10 it will give a negative results. Okay. Total we will have 23 samples. Okay. And out of 25, 15 positive samples, 10 negative samples. So your algorithm has to predict both positive as well as it has to predict the negative also. Okay. So here, what is the formula? We have to give a log 2 of positive divided by negative. So 15 divided by 25 is total number of samples. Log 2, 15 divided by 25. Okay. And here this is for the negative cases. 10 divided by 25. That is negative cases are log 2 of 10 divided by 25. So this is a formula for calculating the entropy. So finally, we are going to measure the entropy for your decision tree algorithm. So this is a formula for the information gain. So the information gain, it can be checked whether your expected outcome you have met with your training model or not, whether you have met the expected outcome or not. Okay, so that expected outcome can be checked with the help of information gain. So this is a formula for entropy, sorry, for information gain. So here also we'll have a data, we'll have values, and what are the values in the attribute A, and here HT is the subset of S, and this A is attribute, and this is a formula. It can be checked to check the information gain, whether what is the expected outcome, whether it has been met with the training model or not. So these two parameters I will discuss with an example. And here I have taken an example to just for a classification as well as for the prediction. Okay. So we are going to discuss this example in terms of in Python, repeat a notebook. Okay. And the next parameter is the is it visible? Sorry, is it audible? Okay, shall we proceed from the decision? So decision is one of the attributes we have to classify whether it's a positive or negative sample. Okay, so this process will be happening in terms of decision, and we'll have stoppage rules is there. To that, in which process, to in which step we have to check the decision making process, and here we will have a condition. Okay, so in what basis, maybe based upon what aspects, either it should be belong to the true or maybe false. If this attribute is less than your C value, it should be true. But it is not less than means we consider it in terms of false case. Okay, and this is the evaluation process. You will have training accuracy, and you will have cross validations. Okay, so all the process will be done in terms of your evaluation process. Okay. And finally, this is the last slide. What are the strengths we are having in terms of uh, with the help of decision tree? It will perform the classification, and already said it will handle both continuous as well as category variable, and it will provide a clear indication of your prediction as well as the classification. Okay. And based upon what are the rules you have been trained, okay. So what are the rules have been generated? It will perform the classifications, and for it will perform for both type of categories, and clear indication of the prediction and classification will be done. And here, what are the weaknesses there in terms of decision tree? It performs poorly with many classes with small set of data, as well as it may not be not suitable for prediction of continuous attributes, and not fit equal for the non-rectangular images. So this is a problem in the decision tree. Uh, the large tree size, if it results in overfitting, and if I have some error probability in the decision tree, it will suffer, it will create some issues, and while taking the decision, when you apply the classification, so some type of misclassification. There's a overfitting in the decision tree node, and it is how you can avoid the overfitting. And okay. Now, just we'll move on to the practical session. Okay, what are the theory concepts I have explained? Just we are going to practice in terms of digital notebook. So I will share two files. So 1 minute, I will share these two files. So I have shared two files. One is bill authentication, next one is petroleum concession. So everyone has received that one. So in the chat box, I have shared the two files. Okay. Okay, I will share in WhatsApp also. Somebody are saying that we are not able to uh, get the two files. So I will share in our WhatsApp group also. Because we are going to use this two data set for this practical purpose. So I have shared this two file in our WhatsApp group also. So if you are not able to retrieve to the chat box, okay, and you can download this two file from the you can download from our WhatsApp group. Okay, I think it is visible. Okay, the screen is visible. So just type online Jupyter notebook. Okay, just follow the steps. What I am doing. Type online Jupyter notebook. So if you have any doubts, any clarification, either just post a message in the chat box. Okay, once again I will explain to you. So yeah, in a Jupyter notebook, we'll have a try classification notebook, Jupyter lab, and try Jupyter with today. The first thing we are going to select the Python because we are going to do the programming Python only. For some, if you have a low, then if internet is slow, means it will take some time. So no issue. If you need some more time, also you can send a message. I will wait. Shall I want to repeat?
Yes, sir.
Okay, 1 minute. So just in Google type your Jupyter notebook. You just type online Jupyter notebook. Okay, you just click this Jupyter notebook. So here you will have three options. One is Python, Jupyter Note, try Jupyter Lab. Okay, we are going to do the programming Python. So that's the first option you have to select. So I need to click the first option, try classical notebook. So everyone got this window.
Yes, sir.
Okay. Then here just go to File, Open. Okay, go to File, Open. Here you will have an option Upload. Okay, you select the Upload, and I have sent a two file. One is bill authentication. Next one is petrol consumption. You select these two files. Bill authentication and petrol consumption. Okay, after selection, you have to click Open. Okay, then it will ask you want to upload in this folder. Yes, you have to click Upload. So I have uploaded petrol consumption CSV. It has been added now. Then next I need to move on to the next file, bill authentication.csv. It is uploading. Now I have added both files, bill authentication.csv as well as petrol consumption.csv. Okay, both file is added now. Okay, so 1 minute. Okay, now it has been added. Okay, you will have option new. Okay, so just click the option new. Here you will have a Python 3. Okay, if you click this Python 3, that editor will be automatically open. Okay, just click the Python 3 option. Okay, now it has been opened. So here, this is the platform for typing the code of your Python for your applications. Okay, so here just we will have a menu. So here file, edit, view, insert, cell, kernel, widget, everything is there. Here Only thing we are going to use the two option. One is run and this is pass. And I think this two or three button is enough for running this code. Okay. So only thing, just we have to type the code line by line. So 1 minute, only 1 minute. Sorry, only 1 minute. 1 minute. We'll type. Okay. We'll proceed. So here, in this practical session, we are going to use two packages. One is NumPy and Pandas. Okay. I know you are not still some of the participants you don't know the basics of Python. Simply, it's a library functions. Okay. Like your normal C program or maybe in Java program, you will import the packages. For example, include stdio.h. Okay, stdio.h is a library function. Like that here, import Java. Okay, so here also in Python, this are the library function is required for doing some type of computation. So I'll tell you what are the library functions we are going to use in this program. One is NumPy, next one is a pandas. Okay, so NumPy it is one of the library function we are using for numerical calculations because here all the values have been stored in the format of tables and you will have a rows and columns. Okay, so if want to perform any operation related to the matrices, we can import this numpy. Okay, and pandas also. Okay, so these are the two functions. It can be mainly used to perform some mathematical calculation program. Okay, so for that only we are I am importing these two functions. One is numpy and next one is a pandas. Okay, so we will move to the practical session. So just I will type line by line. Parallelly, you can also do this process. Okay, so first I need to import the package pandas. So just type import pandas as p. Okay, so just all of you follow the steps. Here, just I am importing the package pandas as a PD. So PD is one of the object. So wherever I want to use a feature of pandas, I can give us a pd dot and we can use the fields. Okay. Now here you have to run each and every line, because while executing each and every line, if there is any error, it will be displayed. Okay. So is it clear? Now I'm going to run this particular line. If there is no error, it will move on to the next line. If your line is having any error, it will be immediately displayed. Is it clear? Shall I move to the next line?
Yes, sir.
Okay. Now I need to import the package numpy. So first I have imported the package pandas. Next I am importing the package numpy. So numpy as np. Okay. So I have imported the package pandas. Next I have imported the package numpy. And here I'm going to import another package that is called as a matplot. Okay. So matplot is one of the library functions. You can draw the graph and you can use it for a mathematical purpose. Okay. Matplot, for example, in Excel you can use it the pie chart and graphs, scatter diagrams. Okay. So all this chart for mathematical analysis, you can use with this matplot library function. I'm going to import this matplot. So just I'm creating an object as a matplot as a PLT. Okay. So I have imported three packages. One is pandas, next one is numpy, third one is a matplot library file. Okay. So in from matplot library, just I'm using one object that is called as a inline. Okay. So in this code lines, we are not having any error, so that's why it is moved to the next line. If a Python program is having any error, it will be immediately reported. Now the fifth step, we have to import a data set. Okay. So I need a data set which have been downloaded. We have downloaded two data sets. One is bill authentication. Okay. Next, petrol consumption. These are two data sets we have been downloaded. Just I am going to use the two data sets in this program. Data set equal to pd dot. So what is pd? Pd is a pandas. I need to read the data set file. So that's why read, it should be in the format of CSV. Okay. For example, normally you will have doc file or PDF file. So we have stored in the file in the format of CSV. Okay. So data set is equal to this is the object I have created. Just I am reading the file. That's why read CSV in bracket which file you want to read, that you should be given here. So before that, these two files should be added in this database. So that's why previously we have opened the file and we have uploaded this two file. If you not uploaded this two dataset file, what will happen means simply it will show an error. So this two dataset file is not available in your folder. Okay. Now I'm just executing this file. Okay. It is not showing any error. Next command, just I'm going to use the dataset dot shape. So what is dataset dot shape? it will display how many rows and column is present in your data set. Okay. In win.csv file, how many rows and columns are present, so that it will be displayed. So here, so I think everyone has got output 1372, 5. Okay. So you will have 1372 columns and 5 rows. This is a this much number of attribute is present in your data set. So that is the use of this data set dot shape. Next command, I'm going to use a command that is head. So head command, it will display the top 5 data of your data set. Okay. What is the top 5 information present in your data set? Okay. So this is the format of your data set. You will have a variance. Sorry. So top 5 elements. So 0, 1, 2, 3, and 4. Okay. So the top 5 element present in your data set is displayed. Okay. And data set dot tail. So this is bottom 5 element present in your data set. Okay. So data set dot head, it displays the top 5 elements present in your data set, and data set dot tail, it displays uh, bottom 5 elements present in your data set. Okay. So now we have to do a classification and which class this particular object should be belongs. Okay. So I am using X and Y. So we have to classify the data. Okay. That's why I'm using a class. Sorry, show some error. Okay. C should be given as a capital letter. K for class. And Y also. Okay. Next, we have to use the learn. We have trained the model. Okay. After training the model, we have to shape and we have to perform a classification. So that is a 3-step I pointed in the theory part. So now we have to select a model. So based upon the model, we have trained the data. Finally, we have to perform a classification. Okay, so I use a sklen dot model selection for splitting the data. Then the next process we have to import the decision tree classifier. Okay, sorry, sklen. Okay, next I need to assign this classifier to the decision tree. The classifier we are going to perform based upon the decision tree only. So classifier equal to decision tree. Next we have to apply the thickness function. So now we can get which decision tree you are using. Okay, so it is displaying the decision tree classifier we have applied for a data set for based upon the age. extreme data set as well as the wide range data. Okay. Next step, we have to apply the prediction process. Just that report, we are going to make a classification report in the format of confusion matrix. So what confusion matrix is nothing but that accuracy level, it will be produced in the format of matrices. So how many data set has been taken and how many data set has been accurately predicted. So that this value will be given in the format of the confusion matrix. Now we need to print the value of confusion matrix. Okay, so everyone is getting this output. Out of 147, 4 has been not able to predict. 141, 3 is not able to predict correctly. So this is a confusion matrix. I think everyone is able to follow this one. Now final classification report I am going to print. Okay. So this is a final output for a given data set. Okay. So what you have been predicted. So this is a precision value. So precision is nothing but your accuracy for your program. It is giving 0.98, 0.97. So here also 9798 out of 151. Here weighted average is 97. Here also the overall accuracy is nothing but 97, 0.997. So what it means that remaining point 0.3 data set is not correctly classified. It is misclassified. Okay. So here this is for example, this is two cases, maybe negative cases. So we have taken 275 supports. Okay. Finally, the overall average of your decision tree is nothing but two. Okay. So we will have a 275 After that, sorry, out of 275, we'll have 157 positive and 125 are negative position in that rank. Okay, and here you will have your final accuracy for your decision tree is nothing but 0.97. So overall your accuracy of decision tree is nothing but 97. So any doubts in this process? If you have any doubts, you can post the message in the chat box. I will repeat. Otherwise, we'll move on to the next example. The similar kind of example for the petroleum consumption, sorry, petrol consumption. Okay, so we'll move on to the next example. There we are going to predict this mean square, all the parameters.
Get out my motherland.
Okay, we'll move on to the next example. So as usual, we have to import this three packages, pandas, and numpy, and your matplot, and here I am going to include the data set, that is petroleum consumption.csv. Then we have to check the format of your data set. Either you can use head or maybe type. So you will have petrol tax, average income, paid highway, population, tribal license, petroleum consumption. So these are the various fields available in our downloaded data set. And next I am using the describe command. So what is describe command it will do means your statistical data, it will be summarized in the format of data frames. Okay. because we are going to use every information as a data frame for your analysis purpose. So that's why describing you are formulating the data in terms of statistical. Okay, that is the use of describe command. Okay, here one of the data we usually we have that data have been formulated based upon for your analysis purpose. So 1 minute, 1 minute. Then some same like a similar procedure we have to train the data set and we have to apply the decision tree classifier. Finally, we have to print the predicted value. Data set. I think the session will be closed within 10 minutes. Okay. Yeah, we are another 5 to 10 statements. One minute. So we are just we are training the data set. Okay. So I have used the petrol consumption. Okay. Then I'm applying the learning model. Okay. So based upon the learning model, it will be given as a training for the data set. Okay. So training the data set for both x plus y axis. Okay. Then I'm applying the decision tree. So decision tree regression. Okay. So the decision tree regression will be assigned to the regression process. Here I was into that one. And based upon the fitness function of x training data as well as y training data. Okay. Then prediction. Okay. So here in y-axis I'm just predicting the matrices. Okay. So how we can predict the value means actual data compared with the predicted data. If the actual data as well as predicted data both are same means, and you can declare that your algorithm is more efficient. Okay. So here you can check it that actual data with your predicted data. For 5 out of 534 is actual data, predicted data is 547. Okay. So actual is 410 and predicted is 414. Okay. 577 predicted is 574. 571 predicted is 554. Okay. 577 predicted is 554. Actually 704 predicted is 554. Okay. And here finally we have to check the eval evaluation of your algorithm. Okay. Evaluation matrices here are applying. So whatever the evaluation matrix we have discussed, all these evaluation metrics there I'm applying. Okay. So print, just I'm going to apply the mean absolute error, that is mean square error. So mean square error is nothing but so what is the deviation between the normal actual value as well as the predicted value. Okay. So here, if MSC value is more, the actual prediction will be more. So here